Okay, so this is a little bit of a review. And then we'll add a little bit more. Okay, exponents. Who can tell me, when I have a number like this, who can tell me what this part is called? There's a name. You may look, you have your notebooks open, so you can look from the notes from last week. What is that number called? It's the big one. Jacinta, a base. If you don't have those notes, because you were gone, this is what you're writing down then, right? So this is called the base. Okay, who can tell me what the little baby number up here is called? And don't call it the baby number. What is it called? Who remembers that long word, James? Exponent. It's on the top of the page. Okay. I'm going to get Okay, when we're doing, most of our exponent work will be with tens as the base. And so when we look at something like this, we refer to it as the power of 10. Because we're not just saying 10 times 2. What are we saying? 10 times 10. Which equals 100. And if you look at your notes, you have some other ones where it says, well, what is, can we go backwards? How do I write this as a power of 10 instead of writing a million? That's so long. I'm going to get a hand cramp from all the zeros I had to write. How do I write that as a power of 10 instead, Sophia? 10 to the 6th. How did she figure that out? How did she know it was 6 that quickly? Luke?
There were 6 zeros.
There were 6 zeros. So she knew in order to get this big number, what happened was she multiplied 10 times 10 times 10 times 10 times 10 times 10. Ooh, who wants to write all that out? Frowny face. Nobody wants to write all that out. Okay. Okay, now you will see, this is your new thing today. This is advanced, but that's okay. I think you can handle it. This is advanced math. Okay, any number if the exponent is a 0 instead of like a 1 or a 2 or whatever, any base to the 0, the answer is 1. If I have 4 to the 0, it equals 1. If I have 75 to the 0, it equals 1. Now, there's a mathematical proof to show you why that is true, but that is kind of advanced algebra, and I'm not gonna, I used to do it to my older classes. I'd show them why it was a 0, but that would kind of be a little too much for you at this point. So, Mrs. Martin, when you get to 6th or 7th, probably 7th grade, she will do the proof to show you why it is a 1 every time. But for now, you are just going to say, yes, Mrs. Barron, you're so wise, Mrs. Barron. Of course, it is a 0. Anything to the 0 is a 1, and we don't know why, but you're going to have to trust me on this. So, I know that it's hard to just take it, but the proof is going to involve more algebra than you really know. So, we will skip that for now.
No, we already know algebra. I know we already know, but like learn
Okay.
more.
In your notebooks, I'm going to give you a few more problems that are a little more challenging, and I would like you to write down the answers in your notebooks as examples. So write the problem, and then write the answer.
You have to write down the problem.
Write down the problem so you know. Go. Write it in your notebook so you have an example. Write it in your notebook, not on your desk. 4 cubed. And I know that that is 4 times 4 times 4. I don't need to write that down. I know what that is, right? Okay, but I might not know in my head 16 times 4. Here's something interesting. Okay, so 4 cubed equals 64. What does 2 to the 6th? See if you can figure that one out. Thumbs up when you know the answer. 2 to the 6th is your next problem. So everybody has this in your notebook. 4 cubed equals 64. Everybody has that in your notebook. 4 cubed equals 64. Now we're doing 2 to the 6th power. And you have to write the answer. I see a lot of people, oh, they're just going crazy. Look at that. All right, let's see what did you figure out? If we have more than one, we'll see if everybody agrees. Salam, what did you get?
I got 12 because I did.
You can't do 2 times 6, Salam. Math jail. Yes, we're putting Salam in there. With a pretty dress. Salam is in math jail. You cannot do 2 times 6. Get her out. Who's going to go visit Salam in math jail? I'm not coming. Sonny, will you visit her, please? Okay, no bail. There's no bail in math jail. Sonny, who can explain, what did you get for 2 to the 6th power?
I got,
All right, Gabby Kenworthy. Okay, did anybody get anything different than 64? Okay, what do you notice is the pattern? We have 2 to the 6th equals 64. We have 4 to the 3rd equals 64. Isn't that an interesting pattern? What do you notice about 2 to the 6th and 4 to the 3rd? Who can raise your hand about something you notice? Peyton?
So I noticed when I wrote 2 times 2 6 times, and I multiplied 2 times 2 3 times, that'd be 4. And 4 times 4 times 4 is the same thing as saying 4 cubed. And that'd be 64.
Okay. Other things you noticed. Stephen?
If you did 4 times 3 equals 12 and 2 times 6 equals 12, they both equal 12.
Oh, if you did it the wrong way and in a math jail, it would work both times. Okay. Austin?
Yeah. What I noticed is that it's with 4 to the 3rd and 2 to the 6th. The 4, it's double. So 2 times 2 plus 2 equals 4, and 3 plus 3 equals 6.
Okay, so he noticed the base was doubled on this one, but the exponent was doubled on this one. That's an interesting thought. Okay, I wonder if that would work for something else. Let's see. How about 3 cubed? And what if we double this? Like, we're following the same pattern. So we have 3 cubed, and we would, oh, we can't really do it with 3 cubed. Let's do, let's do 4 and 8. 4 and 8. So we'll do this one squared, and this one to the 4th. Right? That's the same pattern as 4 cubed and 2 to the 6th. Right? Or not? This has the higher. I don't think I did it right. So the base that's higher is here. 4 and 2. Okay, forget this. Squared.
No, it should be the other way.
I keep getting, why am I getting this mixed up? This base is smaller. This base is smaller. The exponent is wrong. Now will it work?
Can I come and visit?
Okay, does this equal the same thing?
Yes. I get it.
16 and? Yeah. These are interesting relationships.